Homework 2B, lesson 2.08. In the figure at the right, parallel AB, line AB is parallel to line EF. The measurement of BCD is 25 degrees, so that's 25 degrees. The measurement of ABD is 125. What is the measure of BDC? So what's the measurement of here? Okay, so we learned that, okay, we can find out this angle, right? Because this angle plus this angle has to be 180. Once you find that, this angle plus this angle plus this angle has to be 180, right? So that's the hint here. Problem number 9, the figure at the right, lines P and L are parallel. So we got 1, 2, 3, 4. So these two are parallel to each other. Now, Y angle 1 and angle 2, which is not that guy. Oh, that's not 2. So this is not 2. That's 2. Y angle 1 and 2 are congruent. Y 2 and 3 are congruent. And Y 1 and 3 are congruent. Part C should come from the previous two problem A and B. Take it further. Prove that in the plane, two lines that are both parallel to a third line are parallel to each other. So if you have three lines, let's say these two are parallel lines, and also this line is parallel to the other two. So if this is parallel to this guy, this line is parallel to this guy, right? This is parallel to this guy. Then this has to be parallel to this guy. And why? Why is that? It's kind of, if this, one more time, if this line is parallel to this guy, and if this line is parallel to this guy, then this line has to be parallel to this guy. You know, line A, if line A has to be parallel to line B, and line B is parallel to line C, then line A has to be parallel to line C. Why is that? Problem 11, prove that AAS triplet guarantees triangle congruence. Use the triangle congruence postulates and the triangle sum theorem in your proof. So we kind of informally understand that we have three triplets, SSS, SAS, and ASA. But we kind of said that AAS is actually working as well. So let's say we have two triangles like this. If this angle, and let's say ABC and DEF, let's say angle A is congruent to angle D, and angle B is congruent to angle E, and then let's say segment D is congruent to segment, segment BC is congruent to segment EF, then these two are actually guaranteed to be congruent. The reason is that I'm going to give you the biggest hint. If we know two angles in a triangle, we know the third angles, right? If we know one more time, if we know two angles in a triangle, for example 25 and 50, for example, then we can find out the measurement of the third angle. Therefore, this can be ASA, right? Because we can find out the third angle of a triangle by knowing two angles of other angles of the triangle. Therefore, this is the same as AAS is pretty much the same as ASA, right? Because the third angles, we should know that angle. Okay, that's why. So please write that formally as a proof. Problem 12. The exterior angle theorem says that the measurement of exterior angles of a triangle is greater than the measure of either of the two remote interior angles. So if you have something like this triangle and extend one line all the way, then exterior angles right there is greater than either angle A or angle B. So I'm sorry, I extended BC a little bit, and we got triangle ABC, and extended BC, and then we get angle ACD. So we plot the points D on the extension of BC. So that exterior angles has to be greater than either angle B or angle A all the time. Prove that the measure of an exterior angles of a triangle is equal to the sum of the measures of the two remote interior angles. So actually, if you add angle A plus angle B, it has to be angle ACD all the time. So angle A, measurement angle A plus measurement angle B equals measurement angle ACD. Or Y. Okay, that's problem number 12. Problem number 13. For each polygon listed below, prove that the sum of the measurements of its angles is invariant. Then find the sum of measures of the angles for each polygon. Justify your answer. Pentagon, that's five-sided gon. So you got to prove that the sum of the measure of the interior angles, this plus this plus this plus this plus this. So let's say we have pentagon A, B, C, D, E. If we add angle A plus B plus C plus D plus E, it's got to be a certain number. You know, it's not 180 degrees, and it never changes, no matter, as long as that's not concave pentagon. So any pentagon, if you add all the 5 angles inside the figure, it's always what was that? 540? Yeah, it's always 540. And why is that? So that's problem number 13. Problem number 14. Take it further question. Okay, this is an extension problem. So if you want to do it, do it. But I'm not giving you an answer. Alright, so that's problem